Hello everyone, my name is Giuseppe Leccia. Today we explore the Arbitrary Waveform Generator user interface, part of the T3AWG3K series, high performance mid-range arbitrary waveform generator, which is available in 2 up to 8 channels. The T3AWG3K series is a 16-bit multifunctional platform. It combines a function generator, an arbitrary waveform generator, and a digital pattern generator in a single instrument. Let's have a look to the arbitrary waveform generator user interface. Here is the arbitrary waveform generator user interface for a two-channel platform, Channel 1 and Channel 2. It consists of two main areas, the waveform sequencer area at the top and the waveform area at the bottom. The sequencer defines multiple arbitrary waveform entries that will be used to create a more complex arbitrary signal. The waveform area, on the other end, defines each individual waveform entry. Let's take a simple example. We start selecting waveform entry number 1. We have available certain elementary waveforms by default, but we can add here any waveform that we can capture using a digital oscilloscope, like this one for instance, or any waveform that we have created using the waveform editor utility. Now let's select a square wave. Let's assume that you want to have an amplitude from minus 1.5 to plus 1.5 volt. So we select the high and low level. Then we are assuming one repetition and we maintain the length as the same waveform length that we have stored. Let's proceed adding, in this case, a different waveform. We can select a ramp. In this case, we maintain the amplitude plus minus 1 volt. As a repetition, we can set 5 repetitions, and the length, we maintain the same length and the original waveform. Let's now add a DC level. In this case, we have only to set the offset voltage. Let's put 0.8 volt. We repeat also this by 5 times and maintain the same length. Finally, we can add a sine wave. In this case, we want to have an amplitude that is from 0 to 0.5 volt. So now we select the low voltage, 0 voltage. And as a repetition, we want to have 18 with the same length. Now we can continue this process adding up to more than 16,000 waveform entries. Let's generate the signal following this sequence. Here is the signal visualized using a Teledyne LeCroy high-definition digital oscilloscope. Let's zoom in on the signal. So I see my signal, 1 repetition of a square wave, 5 repetitions of the ramp. I see the DC value, and then finally have the 18 repetitions of the sine wave. Looking to the amplitude, as expected, the square wave is plus minus 1.5 volt, the ramp is plus minus 1 volt, the DC value is 0.8 volt, and the sine wave is from 0 to 0.5 volt. How can I capture a waveform with the DSO and then using this waveform the arbitrary waveform generator? Let's first capture the waveform and the trace, save it. Then let's import the waveform into our arbitrary waveform generator just selecting the waveform, pointing out it's an analog waveform, it's not digital, and now the waveform will be available to be used for any waveform entries of my sequencer. For instance, taking what we have built previously, we can replace the ramp with the waveform that we have already captured and changing also the amplitude. So for instance, we can go from minus 1.5 volt to 0 volt. So we can select the high voltage 0 volt, and we can select the repetitions instead of 5, just 1. And now I can generate the new signal. And here is the new signal, visualized with the digital oscilloscope. Let's zoom in to see the details. And now I can see one cycle of the square wave. I see the signal captured using the DSO over here. Then I see the DC value, and finally the 18 repetition cycle of the sine wave. The signal that is captured by the DSO is now showing an amplitude from minus 1.5 volt to 0 volt, as we have defined in our sequencer. This concludes our overview of the Arbitrary Waveform Generator user interface, part of the T3AWG3K series 16-bit multifunctional platform. To learn more, visit teledyne-lecroy.com.